In an introductory chemistry course, you might encounter the words chemical equation. Chemical equation, just like the mathematical equation, consists of some symbols like plus sign, and it's going to have an arrow right in the middle. The left side of the arrow represents the reactant. So these CH4 and the 2O2, those are the reactants. On the right-hand side, those are the products, the CO2 and water. What this is saying is we have one methane gas, two molecules of oxygen. It forms into one molecule of carbon dioxide and two molecule of H2O. Not only is this a chemical equation, but we consider this as a balanced chemical equation. So why are they balanced? And how do we know if something is balanced? Well, one of the ways we can find out this is a balanced equation, there's a clue here, and that's a coefficient. So you see these numbers right in front of the molecule. I'm not talking about the subscripts. The subscripts are the small, tiny number that is related to the that represents how much of that particular atom is within the molecule. For example, for CH4, that 4 is showing that there's 4 of the hydrogen. This 2 is showing that there's 2 of the oxygen within this one oxygen molecule. So there is a coefficient in the front. What does that represent? Well, that shows that there's 2 of the oxygen gas. There's 2 of the water. What about in front of carbon dioxide and the methane? Is there a coefficient here? Yes, there is actually a coefficient there. Oops. There is a coefficient there, and actually there's 1. We just don't write 1. I'm going to go ahead and write 1 for now. 1. Okay. Let me show you an image that represents the chemical balance equation. Here you see that the black spherical, those are my carbons. So my methane has a carbon here and my carbon dioxide a carbon. The white ones, those are hydrogens on both reactant and the product side. And lastly, we have this red ones, right? And the red ones represents oxygen. And let me put that in green. Now, we can tell that this is balanced, not just because there's a coefficient there, but there is a balance between the atom, between the reactant side and the product side. And here's what I mean. If we were to count the number of carbons on the reactant side, so say on the reactant side, we're going to list out carbon. On the reactant side, carbon. How many carbons do you see? See 1. How many hydrogen? Total of 4. How many oxygen? Not O2, but oxygen by itself. There should be total of 4. What about on the reactant? How many carbons do you see? 1. How many hydrogens? You see 4. There's 2 coming from each of the water. And how many oxygen? Oxygen may be split between the carbon dioxide and water, but you see totality of 1, 2, 3, and 4. So you see 4. So if you were to compare the number of the atoms on the reactant and the product side, they are equal. And now we can finally say, indeed, this is a balanced chemical equation, not only because there's a coefficient there, but because there is a balance between the carbon, hydrogen, and oxygen, between the reactant and the products. Okay, same number. Now let's go into a little deeper into the balance equation. There's one more component, and that's these G, or the little parentheses G's. What is that? Well, that shows the state in which the particular molecule is in during the reaction. For all of the G that is here on the subscript of the subscript, well, that's gas. It can be solid, S, liquid, or L, or aqueous. It doesn't necessarily have to be gas. It just depends on what reaction we're looking at. Aqueous, AQ, just means that that particular substance is dissolved in water. And at this point right here, at this particular chemical equation, they're all gas. Can you have mix and match? Can you have a solid on one and perhaps a liquid on the other? Absolutely. Now that you have seen a balanced equation, let me show you what an unbalanced equation looks like. And the unbalanced equation, you could already tell because there's no coefficient there. Well, all the coefficient looks like it's just one, I should say. But just because there's all coefficient is one doesn't necessarily mean it's not balanced. So we do need to check the reactant and the product side, the number of each atom. So let's check. For carbon, there's 1 here. Hydrogen, there's 4. For oxygen, there are 2, right? And what about on the right-hand side? There's carbon, there's 1. Hydrogen, there's 2. What about for oxygen? How many oxygens do you see? There's 2 here, and there's another 1 here, so that's totality of 3. You could already tell this is not balanced because if you look at the hydrogens and the oxygen, they are in different number. Now, in the previous slide, we were able to see the number of carbon, hydrogen, and oxygen based on the spherical drawings like this. But you're not going to have those kind of spherical drawings all the time. In fact, you're probably going to be encountering a balance equation like this, and you need to determine how many carbon and oxygen there are. So let's do this. Carbon, in front of the carbon, you will see the coefficient. There is a coefficient, and that's 1. On the product side, same thing. There's a coefficient, and that's 1 as well. Well, when we count for carbon and we want to know how many carbon are there, we could already tell it's 1, but we take into consideration of how many, what the coefficient is. So first you write how many carbon you see, then you multiply by the coefficient number. And right now our coefficient number for here is 1. Okay, so let's try for hydrogen as well. Let me rewrite this. So carbon on the right, same thing. There's 1 carbon, and I'm going to multiply by the coefficient, which is multiplied by 1. And I'm going to do that for hydrogens and oxygen as well. So let's try on the reactant side. Here's my carbon, hydrogen. I should do hydrogen. There's 4 hydrogen, and my coefficient is 1. If I were to multiply all of these guys together, this is 1 and this is 4. Okay, now for hydrogen on the other side. So hydrogen on the other side, you have 2 hydrogen that's coming from this to this subscript here, and then multiply by the coefficient, and the coefficient is the one I mark in red. So this is my coefficient, multiply by 2, so that would equal to 4. Let's try for oxygen on the reactant side and come back and check the key. Okay, now what about for the product side? For the product side, we have oxygen here. That's coming from carbon dioxide. There's 2 of them. That's coming from the water. The other oxygen, there's just 1 of them. Now the coefficient does differ from the carbon dioxide. The coefficient is just 1, but the coefficient coming from the water is 2. Oh, I should put multiplication. And so there's 2 water here and there's 2 water here. Totality of the entire oxygen is 4. And you can see that there is balance. Carbon is 1, hydrogen is 4, and then oxygen, there is total of 4. We're going to do some more practices in the next slide. Here is a learning check. It says how many elements are present in each of the following molecules. I'm going to do these first two. You're going to try the next two, and then we'll come back together for the next one. Okay, so let's do water, H2O. The coefficient here is just 1. Okay, and so we start off with how many hydrogens based on the subscripts that's shown. So the hydrogen, there's 2. For oxygen, there's 1. Well, you might say, well, no, it's not 1, it's 0. There's nothing there. It's not that there's nothing there. The oxygen is there because there's actually a 1 there, but we just don't write it. Just like how we don't write 1 as the coefficient. Now, the coefficient is 1, so we're going to multiply all of these subscriptive numbers by 1. And I would get 2 hydrogen and 1 oxygen. Let's try for 2 H2O. Okay, so we're going to move on to the next one. So the coefficient here is 2. So first I'm going to write all the subscript ones. And so I have 2 H's and 1 oxygen. And then you're going to multiply by the coefficient, which is 2 for both. So you get 4 hydrogen and 2 oxygen. So you try for calcium oxide, okay, for calcium oxide and 4 calcium oxide, and come back and check the key. And here is the key. So let's try potassium oxide. So for potassium, there's calcium oxide. For K, there's 2 of the subscripts, so 2. And then for oxygen, there's only 1. And the coefficient is at this time 3. So multiply by 3, multiply both by 3. So I get 6 potassium and 3 oxygen. Okay, now I'm going to leave you to the last two and come back and check the key. And finally, here's the key. All of these are just to set you up for success for the next part, which is actually balance the equation like this. These are unbalanced equation, and you need to put a number of coefficient in the front of these guys in order to balance the left and the right side of the equation. When you balance the equation, you do not change the subscript or add any numbers on the subscripts or subtract, but rather you try to balance the equation by adding the number or the coefficient in front of these elements or molecules. So for here, you can see a very clear distinction that aluminum and sulfur, they're not balanced. There's only 1 aluminum here where there's 2. 3 aluminums here where there's only 1 sulfur here. Let's target the aluminum first. If there's 2 aluminum here, how many aluminums should I have on here? Right now is 1. We want 2. So I'm going to add in the coefficient 2 in front of the aluminum. So you probably guessed it. So in front of sulfur, what would it be? 3. So this shows aluminum, there are 2. For sulfur, there's 3. Same thing here, there's 2 aluminum and 3 sulfur. Therefore, you don't need to put anything in front over here to try to balance the equation. There's a 1 there already, so you don't need to try to manipulate it. How about the next one? Let's count how many hydrogen, sodium, and oxygen, and even chlorine are present. On the reactant side, there are 2 hydrogens. How did I know that? There's 1 here, there's 1 here, and the coefficient is 1, so we don't need to multiply by anything. There's 1 chlorine, 1 sodium, and then 1 oxygen. Okay, let's see on the right side. How many hydrogen do you see? 2 chlorine, 1, sodium 1, and oxygen 1, which shows that this is actually a balanced equation and you don't need to add or change to any of the coefficient, because the coefficient 1 to 1 to 1 ratio is the correct way.